Hi, everybody. Today we'll be joined by myself and Carlos to talk about how to build on-chain monitoring with machine learning using Forta and ZettaBlock. Um, I'm Kowalski DeFi or Konstantinos, data analytics or data analyst engineer at ZettaBlock. And Carlos, feel free to introduce yourself here.
Yep. Hey, I'm Carlos. I'm senior data scientist at Forta. Yep, excited to be here to discuss how to build these bots.
We had a minor issue with a live session, but we said we're not going to be deterred and we're going to do an offline session instead. But I hope it's okay. Um, so we'll do like a minor introduction to discuss what Forte and what ZettaBlock is doing for the space, and then we will go straight into the on-chain monitoring with machine learning, which yeah, we'll go into in a bit. So ZettaBlock is a Databricks for Web3 with real-time enterprise-grade Web3 data. You have indexed blockchains, and you can also bring your own off-chain data. You can bring price data, you can bring your own labels, combine it all together in a unified platform, write some SQL, and create your own API, GraphQL API on the other side to build your decentralized applications with. Um, so, Carlos, do you want to?
Yep. Well, Forta is a real-time detection network. It's mostly what we do is like we sit on top of the chains, and we, with the bots that the community can create and that we also create, the transactions or the blocks can be monitored to make sure that these transactions are safe and there is not any type of scam or attack going on. Like there are like a lot of bots running on the network at this point. Like for example, in this picture, there is like it's a screenshot of the scam detector feed, which is it's our biggest bot that it's again real time on all the chains that are thrown there, finding scams and trying to protect Web3. And yeah, today what the thing that we are going to be going over is like how can we use ZettaBlock as a way to get data and to train machine learning models in order to create one of these bots that are monitoring the blockchain on top of it. So we are going to be seeing how can we use this power of having data to build machine learning to help securing DeFi and Web3.
So let's go straight into it then. When doing data exploration, let's go to this window here. So when doing data exploration, obviously you're not going to be running through this 30-day window that I have here. You're going to be running through the whole historical data, but for the sake of this tutorial, we'll be running through less data, so you don't have to wait for the query to run. But in this query, what we do is we check the ETH transfers within the last 40 and then minus 10 days, so a 30-day window between the last 40 days, where the from address of the ETH transfer is equal to the from address of the transaction, so the message signer. The transaction is successful, and we are just getting a bunch of um, uh, wallet address, contract address, ETH amount, and date combinations. And then from that, we get the average ETH amount that was transferred within that 30-day period from a wallet address to a contract address. So if we run this, it should take a few seconds, and it returns really fast. And then with this data, obviously this is limit 100. You could start doing some exploration. You could start picking up some of these wallet addresses, contract address combinations, and seeing anything interesting. So if we sort by ETH amount, there is one here with 19 ETH sent to it in the past in this 30-day window, which is something you might be interested in looking into, or uh, something similar to that. And yeah, so this is where you would be doing all your exploration. Once you're done with your exploration, you're gonna query this live, and Carlos will show us this in a bit. And then once you query it live, you can start training your model and continue with the deployment of it and everything. So, Carlos, would you mind sharing here?
Yeah, I'm just noticing I was on mute, obviously.
No worries.
Yeah, great. Here, so just to have like the context, right? When we are doing some machine learning, in the end, we need to understand our data, and we need to have like the data, we need to have our labels, if we are doing something supervised at least. So what I'm going to show you a little bit is what will be a normal workload for me when I'm working on creating a new machine learning model by using ZettaBlock before we put them into a live bot, what I would do in order to get this data. Then I will just run through it. This is the same query that Constantinos showed. So I'm just going from the same thing. Don't overthink about the query itself. This is a little bit more to show what will be the process and not about the query and exactly what we are doing. So in order to run it here, I literally took a part of the documentation from ZettaBlock. They have one recipe where you write your own query because we're doing something different. But then these parts of codes here are copy pasted from the documentation. So we can just run this thing. Obviously, we need an API key to run this query that is linked to my account so that I can run this query into ZettaBlock. And then here I would just be waiting for the results. And for Constantinos, it took like 8 seconds. For me, it's going to be around the same. I also have to download it, but it's like limit 100. So it's not exactly going to be a lot of time. It's taking much longer than I expected, though.
So this right now is running live on the data lake table. It's and you're getting the data live, which will vary in time depending on how complex your heuristic is and how far back you're looking at. Here we're looking at 30 days, so it's pretty fast. Yeah.
Yeah, I mean, we are looking at 30 days plus we have a limit 100 for the demonstration. So it's much faster than in a real life use case, but still
Also, when you're testing, you don't want to be doing like a non-limit 100 on the UI on your browser. It will probably crash it with all the data. So you probably want to be doing this like what Carlos is doing here on a notebook on your testing. Yeah.
Yep. Great. And then this finished. So now I'm just going to clean the response and something like that. And I have the same, or not necessarily the same, but I have already the results similar to what Constantinos got before. And in a real case, this would be our input. This would be our features that we can use to train a machine learning model, right? But at this point, we don't have any labels still. Like we need to have, if we are going to for something supervised, we have that second step missing. So how can we get those things? And for that, it's when Forta starts working. Because one of the things that we are generating with these bots that I discussed before is they generate labels for different addresses. So we can get information whether the bots that are inside the Forta network think that they are anomalous or not. So it's at least a great first step towards understanding if an address is malicious or not. You can access this information through GraphQL, but there is also like a Python and JavaScript package that mostly have some wrappers on top of that. So instead of having to write myself the GraphQL query, I can just get labels for each one of the addresses that we got from our query, and then I will get the information from them. So this is something that, again, this is running real time. We are getting the real labels from the query from these 100 different wallet addresses that are 97 unique ones. So there are 2 of them that are repeated, which is fine based on our query. So here we would be getting the labels that we will use for training our model. Then after this, what would happen is that we have set of input data. So we have our features and we have our labels. Of course, we need to do some exploration. We need to understand how it works. We need to understand what we want to do. And we need to understand how the queries are distributed. We need to clean them a little bit. So there are like a couple of steps that needs to be done here. But this demonstration was especially seeing how would be like the end-to-end process in both for training and for inference. It's a little bit more difficult because inference, well, it's real time, so everything needs to be working real time, which is always more challenging. So here I skipped all the steps about doing exploration and cleaning the things. So I just incorporated them within like this pre-process class and model class, and then we would be mocking them like, okay, prepare for training, and then training them and saving the model. And with this, we would have like a trained model. After, obviously, this part here would take more than the 1 minute that it took me to explain it, right? Because that is where most of the work from data science or training a machine learning model will come by. But getting the data and then doing the inference, which is the next part that we are going to go into, it's very easy. Like you saw how getting the queries is very easy. You can just save this locally, and then you don't need to query it. It's something that you need to do once. It's quite straightforward, and honestly, it saves a lot of time having everything already aggregated. Yeah, and this is like, up until now, we have trained the model, right? And now what we need to do is we need to do something with that model. Like, data scientists and people who train machine learning models are very good at training models and not using them afterwards and not getting any value out of them, right? So we need to go this extra step further. And that's something that we can also go there. In order to go there, assuming that we want to run it in a Forta bot, we can initialize a Forta bot. Like, there are some agents that help with initializing it, like the project, so that we have all the parts that are needed for getting the model and so on. I explained a little bit here, like there is documentation on the Forta documentation on how to do that. To initialize it with Python, it's literally running this command after you have created the directory where you want to have the model. And that's how you do it. And after that, we will have a bot. Obviously, now we need to write on a bot, right? But in order to do the inference, we need to have the equivalent of the data that we were receiving at the beginning and that we use for training, but on real time, because that's the part that we want to be monitoring. So for that, it's where we need to use the real time API so that we can query data. So I'm going to go back to you, Konstantinos, so that you can explain a little bit how it works in ZettaBlock, and afterwards I will come to how to integrate it into a bot.
So what Carlos has said, just to echo back, we've looked at how to take data from ZettaBlock that are historical data, historical aggregated data, train your model with it, and now we are at the last part where you need to do inference and you want something that will reliably give you the same aggregation in real time, let's say of the last day, because you want to monitor the last day of worth of data, and then based on that data, run your inference. So let's see here. So if I share again here, this. So this is our real-time version of the query. So this is running in the last day. And it's again running through the ETH transfers table and just getting the average ETH amount on wallet address, contract address combination, where the from address is equal to the message signer, the transaction from address, and the status is 1. So the transaction is successful. So if we run this in the real-time DB, it shouldn't take very long, although it is an aggregation, and it's going to give us a lot of results. So like we get a flag here saying you're dumping a lot of data into your browser, which is what we were saying earlier. It's probably not a good idea to be doing that on the browser. But yeah, so then you will click Create API, and then when you're ready, you need to name this Forta Live Inference Bot, and then you need to click Toggle the Real-Time API, which will refresh this code within 5 to 15 seconds. So every 5 to 15 seconds, and then we want to index by wallet address, so we can have fast querying on wallet address level. And then what I'm going to do is I'm going to also create a primary key, which is wallet address, contract address, for this table, which is how the refresh is going to also ensure that also the old data is kept in, and also update the wallet address, contract address combination without creating any duplicates in the table. So here's how we create the API. Should take a few seconds, and then when we have the API, we're ready to use it. And I've already created one, obviously, before this session, and I've given it to Carlos, and Carlos is now going to show us how you can use this real-time API that we just created to do inference on your model that you've just trained.
Yeah, I was muted again, and when you start sharing, you cannot unmute yourself until it's actually running. The things you learn doing this.
That's okay.
Great. So yeah, the same way that before you can do things through the ZettaBlock console, but like if you are training things locally or like on our server or wherever, you also want to have a programmatic way of doing that, right? So the same way that we can have the query before to collect all the data, we can also query on top of the GraphQL database that is generated from the query that Constantino just showed, and that is running on real time. So for that, you just need to have like the URL of the GraphQL, the address, which is one that I picked at random before, but it ended up having a lot of transactions. So it was a great example. So I just end up with this one. And you also need to just write your query, your GraphQL query that we are just getting the contract address and the average ETH amount that the wallet address is sending with the parameter that would be the address that we are interested. And if we run that, ideally what we will get is the information from that particular address, including also anything that has happened realistically in maybe not the last block, but at least up to 2 blocks before, because we are running it, so it's not that fast, and 15 seconds log kind of. So yeah, as you can see there, this wallet is very, very active. So we are getting the data. And the cool thing is that since we are querying into the real-time database, we are getting information that it's very updated. Like we are missing at most 1 block, which means that if we have a model that is depending on that, we can definitely run inference over that and be sure that we are having up-to-date information. But yeah, cool. Now we are in the point where we have all the pieces. So we have a trained model. We have a way of getting historical data from in real time. Because like, again, when you are running with a bot in Forta, you can get information from that particular block or from that particular transaction. But if you want information from 2 days ago, then it's a little bit more cumbersome. And that's where this that is where ZettaBlock comes to help, and we can query the things in real time. So now I'm going to explain a little bit to you how the agent, which is the main part of the bot, actually works. And again, this is focused on Python because, well, I mostly work with Python, so it's a little bit easier, but it's also available in JavaScript. And then afterwards, this is running inside a Docker that it's running. So the agent itself outside, it's running on JavaScript. So there is some layers on top of it, but you can write everything in Python and it works. And here you have 2 main parts that you need to implement. Like, first of all, you need to initialize your bot because there are some things that have like a particular state. Like, for example, the model, when we're initializing the model here, part of what we are doing is we have some environment variable, or we have some local constant where we are saying, okay, the model is located in this path, load it. So you can load the model and you have a class with the model that it's loaded. Same thing with the preprocessing, because you might want to have like one hot encoding, for example, that you might have a stored model in your preprocess class. So you will also get that one. And the same thing with get data, where you would get things like your API key for ZettaBlock, and you will also put the URLs to the GraphQL API or to the live API if it's the one that you are querying. Then after it's initialized, the next thing that you need to do is there are 3 main classes here. You can work with the 3 of them, or you need at least one for sure, which is monitor transactions. So we need to have the handle transaction function, or you can monitor blocks and you would have a handle block, or you can subscribe to other bots within the network and then you would have monitor alert, handle alert. So those are the 3 main things. All of them works somehow the same way, like handle transaction, whenever there are like new transactions, for each transaction, these triggers. And then you just go over them. You have some information from the transaction, so who triggered it, you have some logs, so you have some information from that particular transaction that you can act on. And now that is very cool, because if you just want to see, if you create a bot that is depending only on gas usage, that's all you need. You could just say, like, if gas is over whatever number that you want, you don't need more information, you are good to go, you can develop it there. But when you're working with machine learning models, a lot of time you need some of this extra context and some of this history, right? And this is where the ability to query from ZettaBlock comes into play. So for example, here, this is, again, a very straightforward example just to show how it can be done. This can get much more as complicated as you want. But like here, we receive a transaction event. And then from this transaction event, what we want to get is all the addresses that have been involved into that transaction, for example. And then in this case, what we will do is like for each one of these addresses, we want to get the data, which this get data, what it's going to do is it's going to be calling ZettaBlock. So it's going to be doing the same thing that we did here. It's going to run this query, only that the variable here, it's the address that we are interested in real time. So we are running over the things that are running at that point in real time. Then we pre-process with whatever we need to do, and we do some prediction. Like, okay, is this address a scammer? Yes, no. Overly simplified, right? Like there's, and obviously this, behind this predict and the pre-process, there is a lot of code and a lot of things that needs to be done. But the process is like that one. It's like that. We get information from the transaction that we need. We get information. We get the historical context from ZettaBlock. We process all the data, and then we run the predictions. And after that, we have an outcome. So we can decide, and this is this part here, like if the prediction is over a certain threshold that we have defined, that is one of our constants, then we would say, yeah, okay, this transaction is suspicious. We are not happy with it. And when that happens, what you do is you create what is called a finding. And the findings they can be like quite complex, but they are mostly information about the particular transaction, what is happening, and why it's having, why are you saying that it's actually, there is something suspicious over there. It can get very complicated. And for example, in this case, it's, again, quite straightforward what we're doing. So we need to put a name and a description of what is going on, the type of alert, that in this case is like suspicious, and severity medium, because in the model that we are doing here, we are not saying, yeah, we are not 100% sure if that address is necessarily bad. We are just suspicious about it at this point. So we just put a severity medium instead of like critical, that would be like, yeah, no, we are absolutely sure this is bad. Stop it whenever you can. Then you can have like also a free, like a JSON field that it's metadata. So you can put things that you want, like in this case, for example, we are putting the address and we are adding the prediction value to understand, because then afterwards we can always do like, we can do some analysis about, yeah, okay, we see that if our threshold instead of 0.5 was 0.8, we will be much more precise and everything would work better. Okay, you can have that in the metadata. Here in the findings, you can also add a lot of other things. Like you can add labels that are giving extra information to this address, and they are saying like, okay, this label, this address belongs to a scammer, and then you can query also. If you remember when we were getting the information at the beginning, what we were querying were the labels. So that is how the different bots are actually populating these things. And in the future, if you really trust the previous predictions of your bot, what you can do is like, okay, give me the labels that my bot did over these addresses, and you can use them for having a closed loop for training your data or for evaluating your data. Like it's also very useful for that. After that, we just add these findings to this findings list that we have in the end, and we need to read the function that is handling the transaction or the block or whatever needs to return a list of findings. And those are the findings that the network and what is that is running permissionless, decentralized, etc., actually reads those findings, and that's the thing that is presented into the Explorer. So if you remember when we were on the presentation at the beginning, that there was like some black screenshot. Into that page, you can see all the findings that are generated like this. So if we generated a finding here, that would be, and it was deployed, etc., that would be shown in a list into that in that page. And yeah, this is mostly it. Like once we have this thing, this runs in a Docker. This runs inside a Docker, right? So there is a, when you are generating this file with this starting project, it it also generates for you the Docker file. You need to modify it a little bit according to your necessities. You need to write your requirements for the Python script. We have models, so you need to make sure that you're copying your models into your Docker file. So all those things that are normal with Docker. And after that, what you would do is like you can just run it locally. So you can run it locally with npm start, and then you get your logs. You can see if there is something that is running, if everything is running well, or if you're having some type of problems. And after you are happy with it and everything is running, what you can do is you just run npm publish, and it will be published into the network, which is mostly calling the contract and publishing the Docker over there. It won't still work in the network. Like after a bot has been published, it needs to have 104 tokens staked. Like this is, as of today, it's around 10 euros. It's just to make sure that it cannot be spam and overloaded, right?
No bad actors, yeah. No bad actors, yeah.
Yeah, exactly. I mean, it's affordable, and if you're in some place that it is not, you can always contact us and we can help you with that. That's not a big problem. It's to stop bad actors in the end. And after that, when it's working, it's just going to be starting generating findings, and anyone with a subscription can subscribe to those and start benefiting from the new model that we have created using ZettaBlock.
So a few questions from me. When you're running this locally, and also when you have deployed it successfully, you can push those alerts to a bunch of places, right? Like what other places can I push these alerts to other than the front end, for example, that we can see for the model?
I mean, the front end is where you see them straightforward. Like they are also in a database that you can afterwards query them. Like if you remember what I was doing here from get labels, what we are doing is like we are querying the labels from the database that has all the labels. There is also one for alerts, right, where you can also get information from that. Like that is stored in a place, and then you can just query it in different ways. Like this is the easy way. Well, realistically, going to the Explorer is the easy way because they are already queried for you, right? But
and can you subscribe to these alerts on like Telegram and like Slack and email and things like that if you have something very specific you're looking at?
Yeah, I mean, you can subscribe to the alerts that are generated from bots. Some filters, so that's also very convenient. If you just care about alerts that have to do with your protocol or just with your wallet, you can just subscribe to those. And if there is something that is related to that, you would receive like an email or Slack or Telegram.
I mean, I would be very interested to see if I could run something. Let's say I have my money with a Compound, and then I want to check the Compound contract to see the flows between that and other things. And if they exceed a certain threshold, like let's say liquidity is being drained from that contract, I want to also withdraw my funds from there. So that would be also a very nice kind of use case for the subscription on the alert part that you've just mentioned.
Yeah, I mean, and that's a bot that can be created like much a little bit less complex than having to have machine learning and having to download data in real time and so on. But it's definitely something that can be done on the network.
But this is also feasible, right? And this is what's so awesome about what Forta is doing, that you can write your own heuristics and you can build a machine learning model and also write your own heuristics to feed that machine learning model, which makes it all the more powerful, in my opinion. And then we can also have a look at the scam detector feed if you'd like. I can share my screen, or you can share your screen and kind of show people how it's going to look like when it's deployed.
Yeah, I mean, do you have it open?
Yeah, I have it open. Yeah, I could check.
Okay, then you're okay sharing it.
So,
because then I think it's also nice to see a little bit what the alerts look like and that you can feed them with metadata and so on.
So the output of the model will look something like this, where you're going to get different kinds of alerts. This is the string you're going to be passing in, basically, and some details. This is the fields that Carlos was showing us earlier. And
yeah, you can click on it if you want,
yeah,
on the name of the alert.
Yep.
And here you have all the information, like you have the timestamp, you have the name of the alert, the ID, transaction, the description, so explaining what is happening.
Yep. And obviously you can always click on the blockchain explorer. I actually really like that you guys are using Falcon. It's a very good explorer, and then you can see, you can inspect what actually happened in that transaction as well. But yeah, this is obviously very cool.
Yeah, and like if you go down, well, okay,
So
you already went out,
yeah,
but like down of everything, there's the metadata that, as you can see, it's like it's a free, it's a JSON, so you can do anything. So depending on the type of alert, there's going to be different populated things. So for example, this was for like a malicious smart contract, but it was a propagation. So it was, if I'm not mistaken, an address that already had some bad reputation that was already flagged as a scammer, was created a new alias. Okay, you already clicked on a different one now. So this is a soft rug pull.
software.
So you're getting.
I like
I
the
was going for the one that was
soft drag pull. That's good. Okay, yeah.
like there are two types. Like there are soft rug pull and hard rug pull that are a little bit different. So that's it's not that sudden. It's like, oh yeah, I'm going to do a rug pull, but carefully because I'm very nice.
Right, right. That's interesting. No, but this is very cool, obviously, and you can definitely use this information to also protect yourself from interacting with contracts that you wouldn't want to interact with. So this is very cool. Yeah, and then you can go to the app.forta network website and explore the different bots that are available. So here you can see this is the one we were looking at, which is obviously the most popular one, and then there's also the attack detector feed and a bunch of other ones, like the NFT trader one, simulation bot, funding, laundering detector, etc. Which is very cool. I've actually had a look at a few of them, and I really like the idea behind it. So yeah.
Yeah, very nice. And I think it's very interesting, and it's very community based. Like we have a very active community. Like obviously, like there's a plugin here, but if you want to join, there are like links in a lot of places in the webpage that you can join our community if you're interested in security and building your own stuff. We also put a lot of bounties and so on. So
And your documentation is very well written, so it's really easy to kind of get started, which is a big thing, I think, in doing these things. So yeah, I mean, we had a Q&A session for the live, but we don't really have a live session right now because of some OBS issues. So I guess we could skip straight into the last part, which is the bounty details, unless you have something else you would like to share with us.
no, I was going to do joke questions about simulating the create, but we can go over it. It's not.
Okay. Okay. But yeah, there obviously we have a bounty with Forta, and the we can go over some of the bounty details here. Let me see here. For some reason, okay, here. So some details on how to get started with the bounty. Obviously, we have on the Twitter post, we have the link there. You can apply for the bounty. The Forta team will get in touch with you. Obviously, check your background, see if you can do this task, and then obviously do an interview with you or something. And then after you're vetted, then you're going to get access to ZettaBlock, whitelisted to be able to query and do your aggregations, and then you can start building your model. Basically, you could just start doing what we showed earlier, some exploratory analysis, figure out exactly what you need to do to solve the task that is in the bounty, which is to improve the performance of an existing model that Forta has, specifically targeting the F1 score for an increase of about 10%. And I think you're going to be using a few different chains, if I'm not wrong. I think you're supposed to be doing it on Ethereum data, Polygon data, Binance Smart Chain data, and anything else. I think that's it, right?
No, I think they are the ones that are supported by ZettaBlock that are also supported by Forta. So the intersection.
Yeah, yeah. So these three, and then obviously if you do all that successfully and you manage to get this 10% increase, which is actually not that easy of a task, but it's 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 a fun exercise. You can claim $5,000 in the Fort token and continue to build bots using Forta. Or so that's it. That's pretty much it. I don't know if you have any closing thoughts, Carlos.
No, I mean, just like sorry for the technical problems. Like obviously
Yeah.
it wouldn't be a technical talk if there are no technical problems. That's
So
how it goes.
So I personally tested it with OBS before, and I didn't do it with a managed stream. So with a pre-scheduled stream, I just clicked start streaming, and it worked. But when you have like a scheduled stream, you have to click this managed stream, and then you go to the stream, and then you have to start streaming and then go live. When I clicked start streaming, it showed that data is going to YouTube. But when I clicked go live, it popped up this window saying, "Hey, you actually are not sending any data to YouTube." So we were not able to go live. So what ended up happening is I tried to do it via the YouTube Studio, and that one didn't let me share my screen. So we wouldn't, we were not able to do it
Ah,
because of that. So
yeah,
we
but
decided to do it offline, so we don't waste this time for both of us. And yeah, I feel like we did a pretty good job, I think, at explaining the end-to-end here. Obviously, there's a lot more detail in the end-to-end part for exploration, like you said, building the model, fine-tuning parameters again, maybe fine-tuning your query and your label set and your distribution of data to make sure that you get that 10% increase that you're looking for. So it's not as easy as we made it look, but all the steps are there, and there's great documentation as well from Forta and from us,
mm,
and you can get started ASAP. And
yeah, and definitely since we didn't have the chance to have the live questions, feel free to make
yes,
questions like over Twitter or wherever. Like just find us. Wherever you can find us. Well, that sounded very bad, but Twitter or probably email.
please feel free to add your questions and any concerns you have on the also
Uh,
on the YouTube comments, right? And
yeah,
we're gonna make sure we reply to you within a week or within a few days. Oh, and obviously, yeah, please apply for the bounty if you're interested. I suppose. So yeah, thanks, Carlos, for your time again, and again, sorry for the situation with the live stream.
yeah, it's all good. Like, thanks for having me. It was very fun. Yeah, looking forward to keep using ZettaBlock to build stuff.
Looking forward to what bots are being built by the person who is going to take up the bounty, and I'm curious to see how they're gonna solve the problem of the 10% increase in F1, and obviously excited to see this show up on the Explorer very soon, since this is gonna be a very good bot. So yeah, awesome. Thanks again, and see you soon.
Yep, bye.